Good morning everyone. Myself Tharia here with my teammate Yuchen to present our project Eng2Py. As programmers, you must have came across a situation where you feel the need to look up code. But searching for problems online is time consuming. Our project is a potential solution for this problem. In very simple terms, the problem that we aim to solve is given an English instruction to write a Python program for a sorting problem to generate Python code attempting to solve that problem. The purpose of focusing only on sorting problems is that we want to observe if the language model can learn this specific class of problems better. Our data collection strategy involved combining simple Python problems that can be solved using sorted arrays with different sorting algorithms. A sample data from our training set looks like this: an input statement in English and the corresponding code in Python. We ensured that all the English statements the structure of all the English statements is changed by using strategies like paraphrasing, use of synonyms, etc. so the model can learn the variations and not overfit on a single style of statements. We manually created our training, validation and testing splits so that all the splits are stratified on sorting algorithms, and we also ensured that the model evaluations are carried out on completely unseen combinations. The most compatible model we could find for our project is the T5 model. The T5 model can perform multiple tasks such as machine translation, classification and summarization. Since our project can be seen as an English to Python translation, this model fits efficiently. The T5 model architecture is a standard encoder-decoder model. We fine-tuned this model for code generation as a downstream task. As our project evolved, we found that the T5 model could not perform code generation as it is a model only pre-trained on natural language. So, in search of a model that was pre-trained on code, we found the Code T5 model, which has the similar architecture as the T5 model but a different tokenizer. This tokenizer leverages the syntactical structure a code snippet possesses. The Code T5 model variants that were feasible for us to use considering our computational limitations were the Code T5 small and the Code T5 base variants with 60 million and 220 million parameters respectively. As we fine-tuned this model, we observed that the smaller variant could not produce satisfactory results. So we decided to use that as our baseline model and use the larger variant as our main model.
So to measure the result in a more direct way, we propose two metrics for hand labeling our data and comparison. So in metric A, the result is labeled pass if the generated code has correct syntax and completes the task of the input, otherwise fail. In metric B, the result is labeled pass if the generated code has correct syntax of the sorting algorithm, even if it does not complete the task, otherwise fail. So for simple one, the baseline result is pretty bad. It's all in one line, and you can see it keeps repeating some same piece of code. The simple two result for baseline model is similar to the previous one. The simple two result of our fine-tuned model doesn't have correct syntax and it does not complete the task. So this one will be labeled fail for both metrics. For simple 3, the baseline result is not all in one line this time, but still have the repeating problem. So for our fine-tuned model, the simple 3 result has correct syntax of the sorting algorithm and it can run without error. However, the returned answer is not correct, which means there are semantic errors in the problem-solving part of the code. So it is labeled fail for metric A. Since it has correct syntax of the sorting algorithm, it is labeled pass for metric B. So overall, the accuracy for metric A of our fine-tuned model is 46%, and same for metric B is 68%. We cannot say that this result is impressive, but compared to that of the original Code T5 model, we believe that we improved the result in a meaningful way. In addition, we also compared the result of our model to that of the OpenAI Codex model. And as you can see, this model can generate nearly perfect code, and it correctly solved the problem. When we're looking back on our project, we have spent some time to find an appropriate model and put a lot of effort into hand labeling our data. However, the most difficult part is the data collection. That cost us a lot of time since we underestimated the complexity of our data. So if there's a similar project, we will take this into consideration so that we can save some time and working on to increase the diversity of our data set and add more data so that we can get better results. Thank you.